All right, so we're looking at this one here. We're going to find the quotient of these here. Now, again, like we talked with yesterday, when we find the quotient, it's not too different from what we did with multiplication. Because all we're going to do is we're going to take this, keep the first one the same, change it from division to multiplication, and flip the second one. So we keep it the same and flip the second one. And that's going to be our main key step with changing from division to multiplication. And so we end up changing it to multiplication. So it's not really that different from multiplication, just we have our one main step. Any questions on this here so far? Now, the first one here, 8 cubed minus 27, is going to be a difference of perfect cubes. Because 8y cubed is a perfect cube. And if we take the cubed root of it, we would get 2y. And if we took the cubed root of 27, we would get 3. So we get these two terms, 27 and 3. Now, so if we look at this here, well, the first thing we can look at is the sign, since it's negative. The signs are going to be the same. Sit, always end on a positive note. Yes, same, opposite, always end on a positive note. Now we can plug the first term in, which would be our 2y. Then we'd have 2y squared. 2y to the first, and then 2y to the 0, which would really be 1. Now we can plug the other term in, which would be our 3 to the second. Now we can simplify a lot of this here in a little bit. We'll wait to simplify it to do the square and multiply some of this stuff together. Well, the bottom part, 64y cubed minus 1. Well, this here is a difference of perfect cubes. And if we look at this here, well, the cubed root of 64y cubed is going to be 4 and y. And the cubed root of 1 is, well, 1. Now our signs are going to be what? The same? Positive, positive. Now we can plug in the first term, our 4y. We'd have 4y. 4y squared. And 4y. Now we can plug in our other term, the 1. 1 and 1 squared. Any questions on how we did these two difference of perfect cubes? Any questions on how we did either one of these here? Okay. Now we'll look at factoring the other two. So the top one, we have 16y squared plus 4y plus 1. So we look at this here. Well, since our constant term, the third term, is positive, it means the signs are the same and they match the sign of the middle term, which will be positive and positive. Now we need to look at the factors of 16. That will give us 4y. So what two, well, factors of 16, yes? 1 times 16, 2 times 8, and 4 times 4. So which one of those do we want to use, and it's going to give us 4? Well, what's 4 plus 4? Are any of these numbers going to add together to be 4? No. So just to make sure, we can plug it into b squared minus 4ac to see if this will work. And it won't. So that doesn't work. Now, let me extend the page. So we're going to leave it alone. Now, I'm going to go on and rewrite this bottom fraction here. Four y squared is what? 4 is 16, yes? 4 squared, 16y squared. 4y times 1 would be plus 4y, and 1 squared is... So the quadratic part, we know won't factor, won't do anything, correct? 16 is 16y squared plus 4y plus 1. Wait a minute, does that look familiar? It doesn't look like it. It is it, yes? So we know because that one's not factorable, well, this one won't be either. So it's not factorable. 4y squared minus 9. This one, we know for a fact that it is going to be factorable. Why is that? It's a difference of perfect squares. 4y squared is a perfect square, and 9 is a perfect square. So we will have opposite signs. What goes in the first one? And the other would be? Yep. Because that's the nice thing about difference of perfect squares. Since the signs are different. Yeah, so we could do the square if it was 2y minus 3 and 2y minus 3, or 2y plus 3 and 2y plus 3. Yeah, when the signs are different, we can't just use the square, unfortunately. So we have this here. Now, we'll have to simplify the top of the first rational expression. 2y squared, well, 2 squared is squared. 2y times 3 is plus y plus. Any questions on how we got to this point here? Now, we could rewrite it again so that they're all on the same fraction, or we can just line it. Now, this numerator is technically in parentheses. Now, what's in common on top and bottom? These are the same. 2y minus 3. What else? That is it, because there's nothing else in common on top and bottom. So on top, we're left with 4y squared plus 6y plus 9. And on bottom, we're left with 4y minus 1 times 2y plus 3. I'm just moving it over. So what else do we have left to do? Find our restrictions. Find our y's. Now we can look at the denominators because we have our 4y minus 1 we'll have to look at. We have the 16y squared plus 4y plus 1. 2y plus 3 and 2y minus 3. In the numerator, well, it's just our 16y squared plus 4y plus 1. So we just have these four, yes? Which one of these do I not even have to look at? Yes, that one, because, again, it's already listed. No one's listed, but I would look at it. I would still want to list it. The 16y squared plus 4y plus 1. What do we know about this? Is this thing factorable? Well, it is. It just doesn't have real factors, right? So if it doesn't have real factors, is there any value that will make it equal 0? No, it doesn't have zeros. There's no way to make this 0. So would I try to find out what value would make it 0? Well, no, because it doesn't have real zeros. There's no point in it. It can go away. So I can move these two over here. So now we need to see what values of y is going to make each one of these equal 0. So these here are a little bit harder to look at than some of the ones we've done already, because y plus 5, that's a little bit easier to see what value of is going to make it 0. Well, here we're going to do what? Add 1 first and get 4y equal to. Then divide by 4, and it'll tell me y cannot equal 1/4. Now the next one here, 2y plus 3 equals 0. Well, we would minus 3 from both sides, telling me 2y is equal to, divide by 2, so y cannot equal negative 3/2. Questions on these here? Does anybody have a guess at what the last one's going to be? So we're saying y cannot equal 3/2. So let's see. So here I would add 3 to both sides, which tell me 2y is equal to 3. And if I divide by 2, I get y equals 3/2. So y cannot equal plus or minus 3/2 and 1/4. Questions on this here? Questions on any of this here so far? You ready for the next one? All right. Wait a minute. The second one doesn't have a denominator, does it? Well, what is it? It's 1. And that's the only real difference with these here. So we can still do our first step. It's just we have to remember that because it doesn't have a specific denominator written in, it still has one. It's just 1. So when we flip it, 1 goes on top. The 3x squared plus 5x goes on bottom. So is this any really different than what we just did or what we did yesterday? Well, no, it's just that now we have to remember that the denominator for this is 1. Well, 1 doesn't factor. 4x squared doesn't factor because both of those are a single term. So neither one of them are going to factor. And what do we want to factor first? 6x squared plus x minus 15 or 3x squared plus 5? So the signs are going to be what? Opposite. Uh-huh. I'm going to write this over here so I have a little bit more room. And the factors of 15 are 1 and 15, 3 and 5. What do we think? And if we check this, 2x times negative 5 would be negative 10x. 3 times 3x would be plus 9x, which gives us negative x, and that's what we wanted, yes? Flip the signs. For me, I'm going to have to rewrite that whole thing. Okay, and that would give us the correct thing because the 10x would be positive, the 9 would be negative, and that gives us a positive x, just like we wanted. Okay, let's factor 3x squared plus 5x. What do we do? Factor out the x. And if I factor out the x, x out of x squared leaves me with... Wait a minute. Huh? Yep. And again, these are being multiplied together. So what's in common? 3x plus 5. And nothing else. Yeah. What would the x on the bottom do? And give us what? 4x cubed. What's left on top? Because one's still there. Well, 1 times 2x is 2x. 1 times negative 3 is, yeah, is negative 3. So it's still there. It just doesn't change anything. So we don't put it down. Now, we still need to find our restrictions. And according to the textbook, we wouldn't include x squared or x because it's still there. It's still listed. But the one that is missing is 3x plus 5. And we need to see what value of x is going to make it equal 0. Okay. So what are we guessing? Negative 5 over 3. So let's see. So the first thing we would do is what? And it is negative 5/3. Yes. Well, if we wanted to include the other 0 for x, it'd be 0. Yeah, no, the x cubed, what value of x is going to make it 0 is 0. Now, the textbook's not going to make you find the ones that are still listed or for the big ideas math because it's still listed. And the numerator and the other part of the fraction, because again, we're looking for where these are 0. Well, these are still listed. We found this one, and well, you can't make one 0 because it's just 1. And that's it. Questions on this here? Any questions on this here? Do we need to see another example of a type like this? Okay. What do we do first? Okay. So we change it from division to multiplication. On bottom. Because really the 2x squared plus 2x is over. So we would flip it. Is it going to be easier to factor 6x squared plus 4x minus 2 or 2x squared plus 2x? What's in common? So what's left over after I factor 2x out of 2x squared? Plus? So what is one of the parentheses and the other one going to be? Okay. Is there something in common with all three of those terms? 2, yes? So I can factor it out. Any questions on any of this here so far? All right. So we had to factor the 2 out first because there was a greatest common factor. And we want to do greatest common factors anytime we see them because it's going to make it easier to solve. Now, since the 1 is negative, the signs are what? We'll have x and x. Because, I mean, x squared is going to be x and x. Now, wait a minute. Because if we want something to be the same, I need one of these to possibly be what? X plus 1, yes? Well, the other one's going to have to be 1 because the only factors of 1 are 1 and 1. And well, 1 and 1 and 1 and 1 and 1 and 1 and 1. A lot of 1s. But the factors of 3 are 1 and 3. And we're going to put the 3 with the negative because we need x plus 1 if this is going to work. And we can check it. X times negative 1 would be negative x. 1 times 3x would be plus 3x, which gives us positive 2x. And that's what we wanted, yes? So it does work. But hey, we do have something in common on top and bottom. That would be our and x plus 1. Anything else? 2 and 2 would simplify out. So what's left on top is 3x minus 1. 5x cubed is left on the bottom. All right. So the last thing we need to find is the restrictions, yes? Now, the book's only going to ask for the restrictions for out of these here because 1 doesn't matter. It's only going to want x plus 1. But the other restriction we could look at is with x cubed or just x because those are going to give us the same values. And what's going to make x plus 1 equal 0? Well, this here, x would be 0. That's already said and done. How about x plus 1? X cannot equal negative 1, because negative 1 plus 1 is 0. So x cannot be equal negative 1. Whatever that color that is. We can say it also can't be 0. So these here are restrictions. Questions on this here? Do we want to look at another one of these? Yes? Okay. So what would we do first? 2x squared plus 5x on bottom, and we would have 1 on top, because really this is over 1. Well, 1's not factorable. 6x isn't factorable. But the other two are. Which one do we want to factor first? 2x squared plus 5x? What's in common? X. So we can factor it out. So if I factor an x out of 2x squared, I'm left with plus x out of 5x would leave us with. And that's it for that there. Now for anything to simplify, I need one of these parentheses to be what? 2x plus 5. Because if one of these is 2x plus 5, then they would cancel out, yes? Well, since the 5 is negative, the signs are opposite. Well, one's going to be positive and one's going to be... What are the factors of 5? Well, hey, we have 5 and 1, so it's lining up so far, yes? Factors of 2x squared are going to be, well, we all have x and x, and then we'll have 2 and, well, hey, everything lined up there, yes? So if we check it with our multiplication, 2x times negative 1 would be negative 2x. 5 times x would be plus 5x, which would give us a positive 3x. Yep, that's what we wanted, yes? Any other questions on this here? Okay, what's in common? And 2x plus 5. And that's it, because the only thing left on top is going to be x minus 1 and, well, 1. So, only thing left on top is our x minus 1. And what's left on bottom? And that there is almost our answer. We still need to find our restrictions. Now, I would look at x being 0, or x squared. But we also have our 2x plus 5. We need to see where that is equal to 0. 0, yes. Right, it would be negative 5 over 2. Because if we looked at it here, we would subtract 5 from both sides for those to cancel, telling me 2x is equal to, then we would divide by 2, and x is equal to negative 5 halves. And those there would be our restrictions. Do you want to look at example 7? Example 7. The total annual amount, I, in millions of dollars of personal income earned in Alabama and its annual population, P, in millions can be modeled by these two formulas, where T represents a year with T equals 1 corresponding to 2001. Find a model M for the annual capital income. Estimate the capital income per in 2010. So really, they're just talking about plugging it in. Because if we wanted to, given it in T, 2010 I find a model M for the annual per capita income. If you're looking at almost M is equal to I over P or something like this here and going from here. But I'm not too concerned with this here. I mean, we could look at it later if we wanted to.